When you're talking about protecting billions of dollars in real estate from climate risk, AI seems like the perfect answer, right? It's fast, it's scalable, it's all about the data. But what happens when that digital model slams into physical reality? So the big question is, where does the algorithm end and where does the real-world engineering have to begin? Let's dive in. Here's what we're going to cover. First, the incredible promise of AI. Then, we'll look at exactly where these algorithms hit a wall. We'll walk through the industry standard for resilience, see what a hybrid model looks like, and finally, get into the really high cost of getting this wrong. So, let's start with that promise. Just imagine you're the one managing a huge real estate portfolio. The idea that you can tackle a problem as massive and complex as climate risk with a piece of software, that's not just appealing. For a portfolio manager, that is basically the holy grail. In this quote right here, this really sums up the marketing pitch from a lot of commercial real estate tech companies. It's such a seductive idea, isn't it? Just run the program and boom, it tells you exactly what to do to protect your buildings. No need to hire those expensive engineers. This is the promise we're really going to dig into. Okay, but this is where that shiny digital promise runs into a very harsh, very physical reality. Resilience isn't just code, it's concrete, it's steel, it's drainage systems. That AI-only solution often just collapses under the weight of actual real-world engineering. So let's get into exactly where that line is. The best way to think about it is like this. AI is an amazing screening tool. It's like a health symptom checker you find online. It can crunch enormous amounts of data to flag which of your buildings are at high risk and tell you where to look first. But you would never let a web app perform surgery on you, right? Well, in the same way, an AI can't inspect the actual structure, it can't tell you if a retrofit is even possible, and it sure can't give you a cost estimate that'll actually hold up. For that, you gotta call in a specialist. Let's get really specific. An algorithm looking at satellite photos and climate models has absolutely no idea if the rebar inside a building's foundation is rusting away, which could seriously weaken the whole structure. And it also can't see a roof membrane that's starting to fail or a compromised diaphragm. That's a critical failure point in a hurricane or any high wind event. These are the kinds of things you can only find by actually getting up on the roof. And there's no way it can see that your drainage system is clogged with last fall's leaves, which could turn a normal rainstorm into a catastrophic flood for your building. So here's the bottom line. Without physical, on-the-ground verification, any recommendation from an AI-only tool is just a guess. It's pure speculation. Now look, this isn't just our opinion. The industry actually has a formal rulebook for this. It's called the ASTM Property Resilience Assessment Standard, and it gives everyone a super clear framework for how to do this the right way. The standard basically breaks the whole process down into 3 stages. Now, stages 1 and 2, that's analyzing the hazard exposure and assessing the vulnerability, that's where software and AI are incredibly powerful. But, and this is the crucial part, the standard is crystal clear about stage 3. To figure out feasible solutions and what they'll actually cost, it requires boots on the ground. You need on-site experts who specialize in that specific hazard. You simply cannot automate that final critical step. So this brings us to the real solution. It's not about choosing AI or engineers. It's about being smart and creating a really powerful hybrid model that combines the strengths of both. And this is a perfect illustration of that hybrid approach. A platform like RiskFootprint will use AI for that huge initial screening across an entire portfolio, identifying all the risks from flood, wind, and wildfire. But then, and this is key, it integrates all that data with expert-led on-the-ground assessments to create a real, actionable plan. So here's how that hybrid model really works. On one side, you've got the AI doing what it does best, screening with things like first-floor height estimates and super advanced flood modeling. Then, on the other side, you have human experts doing what AI can't, actually going on site, figuring out feasible retrofits, running a real return on investment analysis, and, so important, providing professional certification. The message couldn't be clearer. AI can screen the risk, but only experts can solve it. So what happens if you just ignore all this? What are the stakes? Well, relying only on algorithms isn't just an incomplete picture. It carries some pretty significant real-world costs and dangers. For starters, you get this false sense of confidence. You think you have a solid resilience plan, but it's really just built on speculation. That leads directly to misallocating capital. Wasting money on a flood barrier for a building that can't even structurally support it. Plus, your recommendations won't be defensible to insurers or regulators. And maybe the worst part?
you might completely miss the simple, most cost-effective solution that a real expert would have spotted in 5 minutes. So we end with this question. Look, AI is an absolutely powerful tool on the journey to resilience, but it is not the final destination. Knowing exactly where its capabilities stop and where human expertise has to take over, that is the real key to protecting assets against the very real, very physical challenges of our changing climate.